Across meadows and through dense foliage, the search for sustenance is constant. For the honeybee colony, survival hinges on discovering and efficiently exploiting food sources. But imagine a bustling city where no one speaks, yet everyone knows precisely where to go for the best resources. This isn't a fantasy, it's the daily reality within a beehive. How do thousands of tiny insects coordinate their foraging efforts, directing each other to exact locations miles away, without ever uttering a single word? It's a testament to a communication system as intricate as it is silent, a marvel of the natural world that has captivated observers for centuries. The continued vitality of a honeybee colony depends entirely on its ability to gather nectar and pollen. Nectar provides the carbohydrates for energy, while pollen supplies essential proteins and nutrients for growth. Without a reliable method to share information about productive foraging grounds, a colony would struggle, its members wasting precious energy on undirected searches. The challenge is immense, finding a sparse, often fleeting resource in a vast, complex environment, and then accurately relaying that vital intelligence back to hundreds, sometimes thousands, of waiting foragers deep within the dark confines of the hive. Our story begins with a solitary scout bee. Driven by instinct and necessity, she ventures forth from the hive, exploring the surrounding landscape. After diligent searching, she might discover a patch of blooming flowers, brimming with nectar and pollen, a true treasure trove for her colony. But simply finding the food is only half the task. The greater challenge lies in communicating this discovery with such clarity that her hive mates can navigate directly to the same exact spot, hundreds of feet or even miles away, without ever seeing the scout's journey or hearing her describe the route. With her bounty collected, the scout bee returns to the hive. Inside, it's a world of complete darkness, a labyrinth of hexagonal cells and tightly packed bodies. Visual cues, so vital in the outside world, are entirely absent here. Yet, it's within this dim, enclosed space that the most crucial part of her journey unfolds. She must somehow translate her experience of the bright, open sky and the distant, colorful flowers into a universally understood language that transcends light and sound, guiding her sisters to the precise coordinates of the newly found food source. The stage is set for an extraordinary performance. Upon re-entering the hive, the scout bee doesn't simply deposit her load and rest. Instead, she embarks on a highly stylized and energetic performance known as the waggle dance. This isn't a random display, it's a sophisticated, nonverbal communication system. The dance is an elaborate series of movements, a straight run, where the bee waggles her abdomen from side to side, followed by a semicircular return to the starting point, first to one side, then the other. Every element of this performance, from the angle of the run to its duration, carries specific information for her attentive audience. The most ingenious aspect of the waggle dance is how it encodes direction. The straight run of the waggle dance points directly towards the food source relative to the current position of the sun outside the hive. If the food is directly towards the sun, the bee dances straight up the comb. If the food is 30 degrees to the left of the sun, the bee dances 30 degrees to the left of vertical. This precise angle, observed by other bees, acts as a living compass, translating an external celestial reference point into an internal, universally understood instruction for the colony's foragers. Considering the hive is completely dark and often oriented vertically, how do the bees perceive up to translate the sun's position? This is where gravity plays a silent, yet crucial, role. The vertical face of the honeycomb acts as their reference point. Up on the comb always corresponds to the direction directly opposite gravity. Thus, the scout bee uses the vertical pull of gravity inside the hive as a stand-in for the sun's position outside. An amazing feat of abstract translation, where the angle relative to gravity's pull indicates the angle relative to the distant sun. Beyond direction, the waggle dance also communicates distance. The duration of the straight waggle run is directly proportional to how far away the food source is. A longer waggle run signals a greater distance. For example, a food source 100 meters away might be indicated by a 1-second waggle run, while a source 500 meters away might involve a 5-second waggle. This remarkable correlation allows the bees to relay precise travel distances without needing any numerical system or verbal measurement. It's a living stopwatch, precisely timed to guide their sisters. The accuracy with which bees communicate distance through the duration of their waggle runs is astonishing. Studies have shown that this system can guide bees to within a few meters of a target located hundreds or even thousands of meters from the hive. This precision is critical for efficient foraging, preventing wasted effort and ensuring that the colony can quickly exploit valuable, yet perhaps ephemeral, food sources. It's a testament to the sophistication of this nonverbal dialogue, allowing for highly targeted expeditions across significant tracts of land. But the waggle dance conveys more than just direction and distance, it also signals the quality and abundance of the food source. A more energetic, vigorous, and prolonged dance, often repeated many times, indicates a particularly rich find. If the nectar is abundant and of high sugar content, or the pollen is plentiful, the scout bee will perform a more enthusiastic dance, drawing more attention and recruiting a larger number of foragers. This nuance allows the colony to prioritize its efforts, sending more bees to the most rewarding locations and optimizing its overall resource gathering strategy. While the dance itself is primarily visual and vibrational, other senses play a crucial supporting role. As the scout bee performs her dance, she also carries the distinct scent of the flowers she visited. This floral fragrance adheres to her body, and as she moves through the hive, it diffuses, providing an additional, powerful cue. Her followers can literally smell the destination. This olfactory information helps them identify the correct type of flower to search for once they reach the general area indicated by the dance, adding another layer of precision to this complex communication system. The waggle dance isn't entirely silent. The movements of the dancing bee generate subtle sounds and vibrations, which are keenly perceived by the attending bees. These vibrations are transmitted through the honeycomb and detected by specialized sensors on the antennae and legs of the observing bees. These acoustic signals reinforce the information conveyed by the physical movements, adding another dimension to the message. It's a combination of physical display, chemical signals, and vibrational cues, all working in concert to paint a detailed picture of the distant foraging site for the colony. Inside the hive, a captivated audience gathers around the dancing scout. Other worker bees, potential foragers, jostle for position, their antennae touching the dancer, their bodies sensing the vibrations. They meticulously follow her every move, absorbing the precise directional angles, the duration of her waggles, and the intensity of her performance. This active engagement is crucial. The information isn't broadcast passively but is actively collected and interpreted by those seeking guidance. It's a dynamic interaction, a living map being downloaded directly into the minds of the next generation of foragers. Once a bee has read the dance, processed its information, and committed to the journey, she departs the hive. Armed with the precise coordinates encoded in the waggle dance, she navigates the open air, using her internal sun compass and olfactory cues to guide her. The accuracy is astounding. These recruited foragers often fly directly to the indicated patch of flowers, minimizing search time and maximizing the efficiency of the colony's efforts. The waggle dance transforms an individual discovery into a collective enterprise, ensuring the colony thrives. This sophisticated, nonverbal communication system is not a recent development. It has been employed by honeybees for millennia, proving its effectiveness and reliability through countless generations. The waggle dance is a testament to the complex capabilities of these tiny insects, demonstrating an ability to convey precise, abstract information about their environment without the need for words, symbols, or even direct interaction with the destination itself. It is a biological marvel, a fundamental cornerstone of honeybee society that ensures their survival and prosperity. The waggle dance highlights a profound aspect of bee society: collective intelligence. No single bee knows the entire landscape, but through this shared system of nonverbal cues, the colony as a whole gains a comprehensive understanding of its environment. Individual discoveries are rapidly integrated into the collective knowledge, allowing the entire superorganism to respond dynamically to changing conditions, finding new sources as old ones deplete. It's a distributed network of information, where movement and vibration replace language, creating a highly adaptive and successful foraging machine. The honeybee's ability to communicate the exact location of food without a single spoken word is more than just a biological curiosity. it's a window into the extraordinary ingenuity found throughout the natural world. It challenges our preconceptions about what constitutes language and intelligence. By observing these remarkable insects, we gain a deeper appreciation for the diverse and complex ways life adapts and thrives. Their silent dances teach us that some of the most profound messages are conveyed not through sound, but through precise, intricate actions, orchestrating perfect harmony in the search for survival. Even after decades of study, the honeybee's waggle dance continues to fascinate and reveal new layers of complexity. It remains an enduring enigma, a vibrant, living example of sophisticated information transfer without verbal cues. As we continue to observe these diligent creatures, we are reminded that the natural world holds endless wonders, often communicated in ways we are only just beginning to truly understand. The silent directives of the honeybee colony stand as a powerful testament to nature's profound capacity for ingenious solutions.